Hari Om. In the fifth unit of microprocessor course, we are currently discussing the data transfer schemes. Apart from data transfer schemes, we need to understand the features and architecture of three microcontrollers: 8255, 8257, 8259A. These are the three controllers we will be discussing in the fifth module. We have already discussed what is the importance of having input-output interface. What are the four major differences that makes the input-output interface unit an important component of a computer? We have seen to resolve these four major differences, such as the different types of devices being connected, the different data transfer rate, the different code and formats, and the different operating modes. So these four differences makes the computer system to include a special hardware component between the processor and the peripherals. Why? Because it needs to supervise and synchronize all input-output transfers. Now these special hardware components are called as interface units. We discussed how the communication link between the processor and some peripheral devices are designed. That includes the interface unit. We have also discussed what are the four major functions of the interface unit. We have seen what are the different what are the different codes or the commands that are used in the function code, which will be placed on the control bus to operate the input-output devices or the peripheral devices. By the time we have also seen how the communication link is created between the processor, input-output units and the memory. How the bus is organized. So three ways of organizing the buses. One, we can have two separate buses. One will be handling the input-output devices, the other will be handling the memory. The second way is we can have common bus for both memory and input-output, but the control lines will be separate for each. And the third way is we can have common data, address and control bus between the memory and the input-output devices for the processor. So we are going to discuss in detail how these three ways or that the computer bus can be used to communicate with memory and input-output is designed. So in the first method, we are going to have the computer with independent sets of data, address and control buses, one for accessing the memory, the other for the input-output. And this is done in computers that provide a separate input-output processor in addition to the central processing unit. So if you want to have independent sets, obviously you need to have separate input-output processor. So this is how it will be designed. The memory and the input-output devices, you will have two processors, one central processing unit, the other one is called as input-output processor, and the input-output processor will be the one that communicates with the input-output devices through separate input-output bus, and this input-output bus will have its own address, data and control lines. In the same way, the memory communicates with the central processing unit, the processor, main processor, and the input-output processor through the memory bus. Again, for the memory bus also, you will have a separate address, data and control lines. Now, the purpose of input output processor, why I need to have an input output processor in this configuration, it is to provide an independent pathway for the transfer of information between external devices and the internal memory. So when you want to transfer data from the input output devices to the memory, you need independent pathway, for which I am going to have the input output processor. And sometimes this input output processor is called a data channel, because it is exclusively used only for the data transfer and not for any kind of processing. So this processor is not going to do any processing, it is going to do only the data transfer. That is why we call it as a data channel. Now the second way is I am going to have isolated input output. What do you mean by isolated input output? The computers use one common bus which will have data bus and the address bus, that is used for transferring information between memory or input output and the CPU. So this is how it will be organized. CPU will be there and you will have a common bus. So when I say common bus, you will have data and address bus, and then the memory and input output devices will be connected to the CPU. And how it will be differentiated? If you want to enable the memory, these read-write control lines will be sent to the memory, or that will be generated with the signals. The same way, if you want to communicate with if the CPU wants to communicate with the input output devices, these control lines will be enabled. So the distinction between the memory transfer and the input output transfer will be made through these separate lines. So if CPU wants to communicate with the memory, these lines will be enabled and this line will be disabled. The same way, if CPU wants to communicate with input output devices, these control lines will be enabled and these control lines will be automatically disabled, so that it can communicate with the preferred device. Now the CPU specifies whether the address on the address line is for a memory or input output. How it will be doing it? The input output read and input output write control lines are enabled during the input output data transfer, or if it is going to be a memory transfer, the memory read and memory write control lines will be enabled. And this configuration isolates all input output interface addresses from the memory address. That is why we call it as isolated input output method. So here what happens, the input output read and input output write control lines are enabled during the input output transfer. So automatically when an address is placed on the common bus, and if the CPU is sending the read write control lines, the system will understand it is the address of input output device. The same way, when the CPU places an address on the address bus, and if these control lines, the read write control line of the memory is enabled, the system will understand the address on the address bus refers to the memory. So that is how it is isolating the input output interface address from the memory address, because you are going to have a common address line. So in the common address line, the CPU will be placing an address. So the system will not understand whether this address is of the memory or the input output device. How it identifies the address? If the input output control lines, the read write control lines of memory is enabled, then it identifies the address here is of memory. The same way, if these read write control lines are enabled, the system can identify the the address on the address bus will be of input output device. So that is why we call it as isolated input output method. Now in the isolated input output configuration, the CPU has distinct input and output instructions, and for each of these instructions is associated with the address of an interface register. Now when the CPU fetches and decodes the operation code of an input or output instruction, it places the address associated with the instruction into the common address line. At the same time, it will be enabling the input-output read for the input and input-output write for the output control lines. So these are the things that we have to understand in the isolated input-output configuration. So when the CPU is fetching an instruction or an operand from the memory, it will place the memory address on the address lines and enables the memory read or memory write control line. Okay, so the thing here is the control lines will decide whether the address on the address line is referring to the memory or referring to the input-output devices. Okay. So that is how you have to understand. Now the third way of having the input-output or memory communication is using the memory mapped input-output configuration. So the first one is called as input-output processor, where I am going to have two separate buses. So there is no problem at all. When the CPU wants to communicate here, it uses this bus. When the CPU wants to communicate with input-output devices, it will be communicating to the input-output processor. Then it will be communicating to the input-output devices through this particular bus. No problem at all. No confusion here. In the isolated input-output, what you are going to do? We have a common bus here and two separate control lines. So the control lines will decide whether the data bus and the address bus is used for the memory or for the input-output device. So if these lines are enabled, the address and the data bus will be used by the memory, and if these lines are enabled, the address and data bus will be used by the input-output device. Now the third configuration is memory mapped input-output. So what we are going to do in the memory mapped input-output, the isolated input-output method isolates the memory and input-output addresses so that memory address values are not affected by interface address assignment, since each has its own address space. Now the question here is, you are going to have only one set of bus, only one data bus, address bus and the control bus, right? Now the question here is, if this is the case, how do you manage whether the signal is sent for the memory or the signal is sent for the input-output devices? So in the memory mapped input-output, what we are going to do? We are going to have same address space for both memory and input-output. Same address space for both memory and input-output. Now this is the case in computers that employ only one set of read-write signals and do not distinguish between memory and input-output addresses. And this kind of configuration is referred to as memory mapped input-output. So in this configuration, the computer treats an interface register as being part of the memory system itself. And the assigned address for the interface register cannot be used for the memory words, and this reduces the memory address range available. That is one limitation when you use memory mapped input-output. So in the memory mapped input-output organization, there is no specific input or output instructions because the control signals are used commonly both for memory and the input-output device. And it can use memory type instructions to access the input-output data also. And it allows the computer to use the same instructions for either input-output transfers or for the memory transfer. The advantage is that the load and store instructions used for reading and writing from memory can be used to input and output data from the input-output register. So that is the advantage here in the memory mapped input output. We are going to have a common common data control and the address line for both memory as well as the input output device. Okay, so what happens if the common buses share? See, imagine I'm not going to have separate control lines. You're going to have only common bus, and these lines will not be there. These lines will not be there for the memory and input output device. The common bus includes data, control as well as the address bus. All the three are available on the common bus. Now, if I am going to have the same control lines here, the limitation is both memory and input output devices will be sharing the same address space. If they are going to have separate control lines, you can have separate set of addresses for input output devices and separate set of addresses for the memory. But if we are going to have a common bus system for the control lines also, then the limitation is whatever address you are going to use here in the memory, the same range should also be there for the input output devices also. So the memory will be, the addresses will be starting from the memory, the first byte of the memory to the last input output device that you are going to connect to the central processing unit. So that is what it says. In the memory mapped input output, same address space must be used for both memory and input output. That is why we call it as memory mapped input output, because the addresses of the memory and the addresses of the input output units or input output devices will be sharing the same address space. So here what happens, the interface register will also be treated as part of the memory itself. So now it imagines the memory along with interface registers also. So it becomes one single unit for the central processing unit. So you are not going to have any specific input output instruction because it is going to be common for both memory and the input output instructions. Input output devices. Now what is the advantage here? I need not have separate load and store instruction used for the reading and writing from the memory, and it can be used to input and output the data from input output registers. So you can have the same instruction, either load and store instruction can be used for input output registers, or you can have input output instruction itself for the read and write memory. Okay, so let us discuss the architecture of an interface unit in the next video. Thank you.